Welcome to this Flood Modeller webinar. My name is Georgina and I've been working as a hydraulic modeller at Jacobs for several years, using Flood Modeller daily to complete a range of modelling work, including for flood risk management schemes and reservoir flood safety studies. Flood Modeller is a fully integrated solution for all your modelling needs and can be used to model rivers, sewers, overland flows and rainfall runoff. Today, I'm going to focus specifically on 1D river modelling and share with you some simple hacks, tips and tricks that I've picked up and found helpful throughout my time so far that should hopefully improve your model building experience. So what will we cover today? I wanted to base this webinar on experiences that I've had during my time as a modeller, particularly as someone who came to modelling with very little prior knowledge apart from a research project during my masters. I hope it will provide some useful tips for those of you who are quite new to modelling and perhaps give a refresher of some of the tools available to help you out to those of you who have more experience. Firstly, I'm going to start by highlighting some of the main file types that you're likely to encounter during day-to-day use of the software. We will then move on and I'll show you some hacks to make your life easier when building 1D river models, running simulations and interpreting your results. One of the things that I found quite difficult to get my head around as someone new to Flood Modeller was the different file extensions that are used and what each of them are used for. I've listed a few of the most commonly used file types on this slide, which you can come back to as a reference point. The majority of these types are types of text file, which can be edited in a text editor or using the Flood Modeller API. If you would like more information on file types, you can access the Flood Modeller knowledge base. I've added a link here to the slide and it's also in your handouts. The page that I've linked here will give you a table of file types, what they are, and how to load them into your project. So now, on to some hacks for building models, which will hopefully make your life a bit easier when using Flood Modeller. So let me just share my Flood Modeller screen. So this is the Flood Modeller interface where all your model files are stored and worked on. It's really intuitive, which hopefully you'll see as I go through the rest of the demo. There is more information and a number of resources and tutorials for getting started on the website and the knowledge base, so do visit there if you would like to find out more. So I'll start by selecting my DAT file, which contains my 1D river network. You can see here that I've added a base map to help with visualization. To do that, we navigate to the Home tab, across to Mapping, and use this drop down here to select a base map. The first few tools I'm going to show you relate to cross sections. These are what makes up the majority of your 1D river network, so it's important to know how to work with them. So the first tip to show you is how to load cross-section extents into your map window. To do that, we simply drag and drop the DAT file into the main map window. It may pop up to ask if you want to show only the activated areas, so we'll click yes here. And then there they'll appear. They'll get added to the layers window here. So if we right click, you'll see we've got a number of options. We can export that as a shapefile. We can also modify the symbology in the properties. The blue lines are drawn based on coordinates within your cross-section units. As you can see here, in this one, Flood Modeller will automatically colour any cross-sections that have incomplete georeferencing using a red line. If we open up this section's data, you'll see that we're missing some of the coordinates. We can fix that very easily using the Fill in Missing Eastings and Northings tool. So you'll find that in the toolbox, Additional Model Build Tools, and within the 1D River Cross Sections section, we'll find the Fill in Missing Eastings and Northings. I've experienced this on a project before where the incoming topographic survey had some points on it which were not georeferenced, but a number of points that were. Or occasionally I've needed to add an intermediate point into the section. This is a really useful tool in these cases because you complete the full set of coordinates without having to do the manual interpolation. It's really simple to use. You just highlight any sections that you want to fix, as I have here. Double click on the tool and it will tell you how many units have changed. If we reopen the section, you'll see that it's now added those missing coordinates. Then if we save the DAT file, you'll see my section is now coloured blue because it has completed georeferencing. We can also use the georeference all cross sections tool. So this is helpful if you have a valid GXY file but your cross sections are missing coordinates. We simply need to load the GXY and the cross section into the layers panel. So let me do that now. And then I'll just use this button here to add my GXY that I want to use. Save it as a shapefile here. And then we want to highlight the DAT file that we want to use the tool for. Double click on the tool. Your GXY file from the layers panel will automatically pop up here. So we'll click OK. Something to be aware of is that this tool will overwrite any coordinates that are already in your DAT file. So it's a good idea to save a copy before you use this tool just in case. The GXY file will define the center points of the cross sections and then coordinates will be added either side based on these. Something that I use a lot in my projects is the Extend Cross Sections tool. This is really useful if you find that your surveyors haven't quite captured the full extent that you need. For example, if you want to represent a larger section of the floodplain using a cross section. To do this, we need to right-click on the DAT file within the Layers panel, click on Start Edit, and I always start by modifying the Extend settings. So double-click on here. This will allow you to choose a number of points per click, so let's go with 5. A minimum distance between the points, so let's choose 0.5 meters. And you can also set a roughness value for the new points, so we'll stick with the default for now. So let's say I need to extend this section here. All I need to do is make sure I'm in edit mode, which I am. Click the cross-section line. Click extend for whichever bank I want, so this is the left bank. Then choose where I want my section to be extended out to, so let's go with here. Click there, right click and say finish shape, and I can stop my edit and save it. So now if I open up that cross section, you'll see I've got some additional points here on the left bank. What you'll also see is that I'm currently missing any elevations for those points with the missing data flag. What I can do here, if I have a DTM available, is pick up those elevations from the DTM. So I've got a LiDAR grid added in here. Let me just make my section editable again. So all I need to do is highlight that section again, click the Set Missing Z button, choose the DTM that I want to use for my elevations. So obviously now it's the LiDAR. And then again, save my edits. Hopefully this time when I open up that section again, you'll see we've now got some elevation data associated with those extra points. As I said, that's one of the tools I use most often in my work. I often find that I need to extend sections beyond the extent that's provided in the topo survey. Speaking of topo survey, have you ever realised that some of your sections have been taken the wrong way around? I've known this to happen a few times and it seems to be particularly common around structures. I've recently worked on a project where the survey for almost the entire watercourse was taken right bank to left bank. It sounds like a nightmare, but once you realise you've got that issue, it's very easy to fix within Flood Modeller. So let me turn that LiDAR off. Let's say this section here has been taken the wrong way around. We'll open it up and note that the Y value on the left bank is 18.54 and on the right bank we've got 16.88. So all we need to do is highlight that section, find the reverse selected cross-section tool, double click on that. It will tell you how many units are affected. So if you've got a full watercourse like I had for that project, you can select all of the nodes at the same time. Then if I open that back up again, you'll see my section's been reversed. So I've got my Y value that was on the right bank now on the left bank. And similarly, my previous left bank value is now on my right bank. So on to the next tool. There are a number of reasons you might need a river centre line. For example, if you're working on an Environment Agency map edit project, or if you're producing figures for a report, it's likely that you'll need to show the centre line of the watercourse. This is easy to create using the Generate River Centre Line tool, which is here. All you need to do is use the cross-section file from your layers panel. So I'll select number 1 and then choose a location to export that shapefile to. Click on OK, and as you can see, if I just turn those sections off, I've now got a centre line that runs through the middle of my cross sections. A river centre line can now be exported, and it's also in that file location that you navigated to, and you can use it for whatever you need it for. One of the ways we can make use of the centre line is to generate more cross sections using the cross section generator. This is a really useful tool for small channels in particular, if you're having survey issues or if you need some more data in an area that you're missing survey. If we select the tool, that tool there, you add in that centre line we just generated, so it's automatically populated because it's in my layers panel. But alternatively, if you have another shapefile that you've generated, you can add that in there. You can specify a DTM and also a nodes layer here to define the labels for your cross sections. They're both optional, so if you don't specify a DTM, your elevations will all be set to that missing data flag value, which is -9999. You can specify the naming convention here. You can set a Manning's value here. You can also define how far apart you want your sections to be. For example, you can choose each point along the centre line or every 25, 50 or 100 metres, whatever value you choose. Cross sections are drawn away from the centre point, so these options here specify the width of your section and how many points you want along that distance. Finally, you just need to set an output file location here. So I'll click OK and turn my previous file off. You'll see here now that we've got cross sections generated at each point along my river centre line. Okay, so enough about cross sections in particular. Let's move on to some visualization tools briefly. A really useful tool here, which I have to admit I learnt about relatively recently, is the import visualization from another GXY file. More often than not, you won't be starting completely from scratch with building a model. You'll inherit one that requires updating. I found this tool really useful in cases where I've inherited a model and when I've loaded it into my flood modeler, the nodes are not correctly located. So as you can see here, we've got a bit of a mess. All we need to do is go back to our network panel, right click on General, select File and Import Visualization from Other File. Here you can navigate to a predefined GXY file. So let's choose that one. All you need to do, because that GXY file contains node location data, is click Open, and that will tidy up your DAT file based on the locations of those nodes within the GXY file. So a quick look over some more general tools. Something I use really regularly is the Sort Initial Conditions tool, which is in the 1D River Networks drop-down. Here. This is particularly helpful when you're replacing cross-sections with new survey data. I personally delete the original unit and import the new one from the surveyor's DAT file. This means it sometimes comes into my initial conditions panel, which is here, out of order. So by using sort initial conditions, I can look at my initial flow and stage values in the order of the network and check that the values are sensible when I compare them to neighbouring nodes. Global edit tools are really helpful for making changes to your model in a few steps rather than taking the time to go through your units one by one. An example I can draw on here is updating the floodplain roughness using the roughness tool. If during a model review you find that your floodplain roughness is set to 0.05 Mannings, and on inspection you actually think it should be 0.04, the global edit tool can be used to update all the values within your cross-section at once. So we select the tool, which is in global edit and roughness. You'll get a pop-up with multiple options here. So you can fill in the details as you wish to change them. So I'm going to use change to set value, and we want to change it to 0.04 where the value equals 0.05. You can tick these boxes here to apply it only to the selection. So in this case, it will only change it for the node that I've got highlighted. If I untick that, it will apply it to the full network. You can also see you can tick on or off to include bridges or apply to in-bank, out-of-bank or both. So let's click OK on that. It will tell you how many lines have changed and for how many units. If I open that back up again, you'll see now that my Mannings N that was previously 0.05 for the floodplain section is now changed to 0.04. Finally, the 1D health check is a great tool to use when you're building models. It will highlight any issues or non-conformities within your network. You'll find it in model review tools. I'm just going to search for it here instead of opening it up. So it's here. If you click on that and save the model, it will pop up with this here, which gives you a list of options of checks that it will run. If you click on Run Selected Checks, it will give you a report that looks like this. Some of the checks, for example, include the presence of bank markers or checking for sensible coefficient values within spill units. It's a really helpful output, but it does need to be interpreted carefully. Just because the health check throws something up does not mean it necessarily needs fixing. For example, a spill coefficient might be purposefully low for stability purposes. It should be used in combination with knowledge of the model and experience. So moving on to hacks for running models now, and I wanted to highlight a hack for running multiple simulations at once. This is helpful, for example, if you've got a suite of AEP events to run your model for. You'll need to create the simulation files for each run you want to do, but once these are set up, you can use the batch runner to run them all at once. It's time-saving, efficient, and you can view the progress of runs all in one place. So to find the batch run option, you need to navigate underneath the Simulations tab and click on Run Batch here. The window will pop up. You can either add simulation files from the project if they're already loaded in, so you can see that mine are here. Tick that there. Or you can also add them from a File Explorer location using that button there. They'll be added to this list, so you can select whichever simulations you want to run. I'll click all of them and then tick Run Selected. Once your simulations have started, you'll be able to click the Detail button, which will give you a progress window for each running simulation. You can see here. You can maximize these or bring them back to show all of them at once. Another handy feature to point out here is that you have the option to automatically post-process your simulations by ticking this box. Alternatively, you can post-process simulations which have already completed by loading them into the batch runner, specifying the post-processing tasks that you want to do, and selecting the Run Post-Process button, which is this one here. I'm just going to cancel those, select them first, and click cancel so they're not running in the background, and close that down. So let's move on to some hacks for viewing and working with results. You've worked hard to build your model, you've run your simulations, and now you want to visualize results and see what's happening in the system. There are a number of features within Flood Modeler that help you to do this. So let's start by graphing some time series. Let's say, for example, you want to examine the water level upstream and downstream of this structure here. Did you know you can plot both of these node time series on the same graph by simply highlighting both of them at the same time? You can do this for multiple nodes at once. This is really helpful when you're performing checks, and you can grab the flow time series from your inflow unit to check it's replicated in the connected node. So to do that, all we need to do is highlight the nodes that we want, right click and select time series. We'll load in some results, so these are some that I ran earlier. I'll just do it for the 1,000-year event for now, so you can choose in your time series what you want to plot. So we'll stick with stage and select plot, and this will pop up. You can see we've got the two nodes here on the same graph. As well as time series, we can plot cross sections and results on them. We can plot one of our events on this one here. So all we need to do again is select the node, right click and select the cross section. We can choose the 1,000-year run. We'll plot stage and bed elevation. And you can see this is your starting water level in your simulation. So if we click play and play there, that will animate the full length of your simulation. You can also plot multiple maximum water levels on the section. So if I go back and plot cross section again, if I select all of my runs and then choose to plot maximum stage instead, that will come up and plot each of my maximum water levels from the runs that I have on the same plot. This is really useful for quickly checking glass walling in your cross sections. So you can load results onto one section, as I just showed you, and then use these arrows to scroll through the network to check if you've got out of bank flows. If it's a long section you're interested in, you can also do similar things with these. Select the nodes you want to add to your plot. So let's just take a random assortment here. You can right click and plot long section. We'll do it for the 1,000-year only for now. You'll see you've got the same options as for the time series. If we choose to plot that, you can play that through as an animation. And similarly to the cross sections, you can also plot the maximum water level for all of your events, and that's really helpful for checking stacking up. Finally, I want to show you the Tabular CSV tool. This is one of the most helpful features for exporting and working with your results. So you'll find it under the Results tab here. The window will pop up and you can see there are a variety of things you can do here. You can export time series from your simulation results, so that can be any of these variables here: flow, stage, velocity, mode, etc. You can also export maxima and minima, which is really helpful if you don't need the full time series but just need the maximum levels. The node selection tab allows you to select which nodes you want results for, so that might be everything in your network or just a select few. For example, if you're working on a road scheme, designers might want flows specifically through culverts. The thing I use Tabular CSV for most is to export the initial conditions. Something I often do when initializing a model is run a small magnitude event, for example a 50% AEP, run it for a long time and then export initial conditions from the last time step, so we get a nice base flow level in the channel. Tabular CSV is perfect for doing that. It'll export an IIC file, which you can then read into your simulation file or import into your network.